So how to solve a triangle if it is a right triangle. So in this video, I'm going to go ahead and give you a problem to solve. We'll do it. If you're trying to practice this, here's the problem. Solve the triangle ABC with angle C being 90, angle A being 20, and little a being 3 centimeters. And so I'll pull that picture up here. This isn't uh, This isn't perfect by any means, but here's a little image of a right triangle with an angle of 20 degrees and an angle of 90. So here would be capital C, here would be capital B, and here would be capital A. And we know that the lowercase letters are across from those big uppercase letters. So little a would be 3. Little c would be your hypotenuse, and little b would be this side down here because it's across from each of those. And what does it mean to solve the triangle? Well, it means that we want to find all the missing information. So in our case, we are missing angle B, we are missing little b, that side length, and little c, that side length. And so we're going to find those using the trig identities. So on the right here, I have written sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So this is how we're going to solve these since it's a right triangle. If you don't know how to do this, or you don't know what I'm talking about with sine, cosine, tangent, you might go find a video that deals with just the introduction of these three terms. One way I do have my students, however, memorize this is with a word so, ka, toa, or a sentence, or however you want to say that. It's just a mnemonic device to help them remember which is opposite hypotenuse, and opposite and adjacent. So if we go into this thing, angle B is pretty easy to find. We'll find that first. Angle B, hopefully by this point that you're studying trigonometry, you know that triangles in 2 dimensions like this with Euclidean geometry add up to 180 degrees, all the angles inside of there. And so we know that 90 plus 20 plus angle B has to be 180 degrees. And so you can go ahead and, 90 and 20 is 110, and then plus B equals 180, and then you subtract 110. Not that you need all this fancy algebra, you could do this probably in your head most of the time, but we know angle B then is 70 degrees. So that's one of the sides figured out for us. The other two are going to be a little tougher, but not much. And so I go ahead and label this thing. 3 is opposite. I'm going to choose the 20 degrees as my angle since it was given. So 3 is opposite. It's opposite that angle. B is adjacent to that angle. And C is your hypotenuse of the right triangle. Remember, hypotenuses are the longest side, and it's also across from the 90-degree angle. So you need that part of it. All right. Now the next thing you do then is decide on which one you want to solve for. Do you want to solve for C or do you want to solve for B? I'm going to go ahead and start with B, which is my adjacent. And since I'm given opposite, if you go to the sine, cosine, tangent ratios that I have, opposite and adjacent, the only one that deals with is tangent. So I'm going to go ahead and set that ratio up. So tangent of my angle, which in our case was 20 degrees, equals opposite, which we knew was 3, over adjacent, which we know is B. So we'll go ahead and find tangent 20 with the Google calculator. That just seems like that's easy. It's already up here, but I'll clear this out. And so you just make sure your calculator's in degrees. It's in degrees, so I'm going to go tangent and then 20 degrees. I always like to close my parenthesis. You don't need to necessarily, but So it's 0.3639 or 0.3640 if you round that. So 0.3640 goes in place of tangent 20. And I'll put that right here. So 0.3640 over 1 equals 3 over b to make it a proportion. You can do whatever methods you were solved. I always tell my kids to cross multiply, but that's always never such a great thing. You're really coming up with a common denominator of b. And so a b is missing here in the bottom. So we're taking this times b over b to get a common denominator of b. And so we've got 0.3640 b over b equals 3 over b. And then you multiply the whole equation by b, and your b's cross out. B divided by b is gone, and b divided by b is gone. So it's 0.3640b equals 3. And so now to solve this, we're going to divide by 0.3640 on both sides of the equation. And that'll give us an approximation of the answer. So 3 divided by 0.3640. Or you could do with your calculator 3 divided by the answer, if it's already stored in there. And so we know that length is, for B, is 8.2 approximately. So we've got B. So when you go back, so we've got 8.2, and now we need to find C, which is the hypotenuse. And again, we're given opposite. So we've got opposite and hypotenuse. We go down to our sine, cosine, and tangent. And sine is the one that deals with opposite and hypotenuse. So we'll do the same thing. So sine of 20 degrees, the angle we're dealing with, is opposite, which we knew was 3. Hypotenuse, we don't know, it's C. And you do the same thing. You find your calculator. We go sine 20 degrees, close my parenthesis, and it's 0.3420. So we'll plug that in. 0.3420 equals 3 over C. This time I'm just going to cross multiply. I've shown my work. You kind of know what I'm talking about. C is, so 0.3420C equals 3 times 1. And then so C equals 3 divided by 0.3420. And 3 divided by 0.3420 is 8.77. So we've got C and B. So angle C is about 8.877, rounding it up. And B is 8.2, and angle B is, we found that as 70 degrees. So that's one type of problem. Now I'm going to show you the second type. The problem is we're going to solve the triangle ABC with angle C being 90, little b being 9 centimeters, and C being 3 centimeters. And again, I have a picture. Typically I just draw a rough sketch of that, but this will be good enough. This image, I made a really kind of a nice one for you. So, and it's actually proportional, so then the angles should make sense. So this is angle A again. Angle C was 90, and angle B was the one that's missing up there. We have a 9 and a 10, so this would be little b, and this would be little c. Again, we've got sine, cosine, tangent that we need in here, and I'll put those in really quick. So this time we don't have necessarily an angle to start with. We don't ever start with the 90-degree angle when you're using SOHCAHTOA or sine, cosine, tangent and a right triangle. So I'm going to start with B this time just to give you a different look at the triangle. So B, little b now, then would be opposite because it's opposite the angle I chose. Little c is always hypotenuse, again, because it's across from the 90-degree angle. Here it is. And so that means little a, which is right here, is adjacent. Okay, now little a, again, is across from big A. Here's big A. So that's why it's little a, but it's also adjacent because it's beside the angle B here. So let's find maybe little a first. Now I'm not going to use SOHCAHTOA for that, or sine, cosine, tangent. I'm going to use Pythagorean Theorem, because this is a right triangle. And if you remember Pythagorean Theorem, a squared plus b squared equals c squared. Messed up on my c there. And so in this case, we know a squared, the one we're trying to find, plus b squared, which is 9 squared, equals c squared, which is 10 squared. So a squared equals 81, plus 81 equals 100. You subtract the 81, and we know a squared equals 19. Then you would root both sides to eliminate that square, and we know a is exactly equal to the square root of 19. Now, if you need to find that answer, get a calculator out. I can tell you it's a little above 4 and a little below 5, which might be enough for you. But to do it, square root 19 equals, didn't close my parentheses, but it didn't matter, 4.4 approximately. So we know a is exactly equal to square root of 19, approximately equal to 4.4, depending on what you round to. Where we only have one digit, if you're as our significant digits, your answer is 4. If we were following significant digits, or sig figs. So now let's find angle B. So angle B, and it doesn't matter what we choose. I like to choose what's given. This 9 and this 10 were what were given for sides. 9 is opposite, 10 is hypotenuse. And so the one that deals with opposite and hypotenuse, again, is sine. So there it is, sine theta equals opposite over hypotenuse. And so we would I always like to write that ratio. So sine, we're finding angle B, and angle B is opposite over hypotenuse, which is 9 over 10. And so in this case, we got to find the angle, which we have to use inverse sine to do that, or the inverse trig identities. So B in this case is equal to the inverse sine, or arc sine, sometimes it's called. I'll put that in there. Either one of those notations are just fine. So sine inverse, or arc sine, of 9/10 is going to be our angle. So in this calculator, you hit inverse for the inverse button, and it gives you sine -1. And I love how it says arc sine. And then it'd be 9 divided by 10. Close that parenthesis, hit equals, and so about 64.2 degrees is angle B. So this is approximately equal to, we'll just call it 64 degrees. I already forgot the decimal. Okay, 64.2. Good enough. It's rounded to the nearest degree. So angle B is 64 degrees. So now it's just, that triangles are equal to 180. So 64 plus angle A equals 100, plus 90, equals 180 degrees. If you subtracted 180 from 90, 64 plus angle A is equal to 90 degrees. So A is simply 90 minus 64 degrees. And so 90 minus 64 degrees, back to the, without getting the calculator out, that's 9, that's 10, or 8, and then that remains to 10. So that's 6, and 8 minus 6 is 2, so we're looking at 26 degrees. And so there is solving the triangle. We know A is 26 degrees, little a is square root of 19 or 4.4, and B is about 64 degrees. So I hope this helps. Kind of a little longer video than I wanted to make, but hope it helps, and good luck, and see you next time.